Hello, good morning to you all. My name is Nalu Anthony, Junior Secondary School Section Maths Teacher, Solid Base Private School, Enugu. Now, this morning we shall be discussing on a topic titled Factors and Multiples. And under Factors and Multiples today, we will be talking in details more on LCM. Now, before we start the class proper, I would like to define factors and multiples. Factors are simply values that can divide through another value comfortably without having a remainder. Okay, now those values that were divided through are now called multiples. Now from the first paragraph we have here, we said if a number m divides another number n exactly, then we say that m is a factor of n and that n is a multiple of m. We give an example. We said 3 is a factor of 12 and 12 is a multiple of 3. Now 3 is a factor of 12 because 3 can divide through 12 comfortably without having a remainder. So LCM simply stands for least common multiple, or is the lowest common multiple. Now LCM is the least non-zero number in a common multiples of 2 or more numbers. Okay, so let's solve the problem so we can have more insight and understanding on the topic of discussion for today. Now there are two distinct methods you can actually use to solve LCM problems. Now the first is factorization method and the second is long division method. So factorization method is simply a method you use to solve LCM by looking for the prime factors of each of those numbers. You have to look for the LCM and selecting the highest power of the factors there and multiply them together, that is, find the product to give you the LCM of the numbers. Now let's take this example. Find the LCM of 12, 27 and 40. So what we need to do now is to find the prime factors of 12, 27 and 40. Now the prime factors of 12 are, you check the least prime number that can divide through 12. Okay, but before you can do this, you need to have a proper understanding on what prime numbers are. Now prime numbers are simply numbers that can be divided by 1 and itself. That is to say, a prime number has two factors. Now a number that has more than two factors or less than two factors is not a prime number. So the first prime number is 2, not 1, because 1 has just one factor. It can divide through itself and no number else again. Number 2 can be divided by 1 and itself. That makes it a prime number. So prime numbers from 1 to 10 are 2, 3, 5, 7. Okay, now in that order. Okay, so to find the prime factors of 12, the least prime number that can divide through 12 is 2. So 12 divided by 2 gives you 6, and 6 divided by 2 gives you 3. So 3 divided by 3 gives you 1. So the prime factors of 12 are 2, 3, 2, 2, 3. Okay, now look for 27. The least number that can divide through 27 is 3. 2 can't go through because of the remainder. So 27 divided by 3 gives you 9, and 9 divided by 3 gives you 3. So 3 divided by 3 gives you 9. So we move to 40. The least prime number that can divide through 40 is 2. 40 divided by 2 is 20. 20 divided by 2 is 20. 10 divided by 2 is 5. And 5 divided by 5 is 1. Okay, now when you take a close look at this number, you see that the least prime factor from the prime factorization method we adopted on the individual number is 2. The least number there is 2. Now when you take a close look at the numbers you have to find the LCM, the one that has the highest power of 2 is 40. Okay, so we're going to pick the power of 2 there, which is 2 raised to the power 3, and we'll check the next least number after 2 is 3. So the column that has the highest power of 3 is 27. So we'll pick 3 raised to the power 3 there, and 5 is just alone. So to find the LCM of this method, to find the LCM of 12, 27 and 40 using this method, we simply say 2 raised to the power of 3 times 3 raised to the power of 3 times 5. Of course, we know that 2 raised to the power 3 is 8. 2 times 2 is 4, and 4 times 2 is 8. Then 3 raised to the power 3 is 27. 3 times 3 is 9, and 9 times 3 is 27. So when you multiply 8 times 27 times 5, that will give you 1000 1080, okay, to give you 1080. So that is a prime, that is a LCM of 12, 27, and 40 using the factorization method. So let me just show you this as a quick reminder of what we are talking about today. Now I want you to take a close look at this. Now take a close look at this. Calculate the least common multiple of 12, 40, and 27. Now the prime factors of 12 are 2 raised to the power 2 and 3, which is 2 times 2, 4, 4 times 3, 12. And that of 40 is 2 raised to the power 3 times 5, and 27 is 3 raised to the power 3. Now when you take a close look at this, you see that 40 has the highest power of 3 there, okay. The power of 2 rather, between 40 and 12 are not the same. That of 12 is greater than that of 40 is greater than that of 12, okay. So we'll pick 2 raised to the power 3 times the next number is 3, and it's just alone, so we'll pick 3 raised to the power 3 times 5. Now when you take a close look at this table, these are prime factors, okay. The prime factors of 12, 40, and 27 are 2, 3, and 5, okay. When you divided through 12 with the prime factors, you find out that 2 appeared 2 times, okay. And when you divided through 40, you find out that 2 appeared 3 times, and through 27 there was no 2 there, because 2 can divide through 27 comfortably, okay. When you divided 3 into 12, we got 1. 40 cannot be divided by 3. 27 can be divided by 3, we have 3, okay. Then 5 cannot divide through 12, cannot divide through 12, cannot divide through 27, but can divide through 40. So we said that the highest power of 2 from this factorization method is 3, which existed in 40, okay, because you can have or get factors of 42 in 3 places, okay. So to find the LCM of these 3 numbers using this method, we'll pick the highest power of 2 here is 3, that's the maximum, and it existed under 40, so we'll have 2 raised to the power 3 times 3 raised to the power 3 times 5 raised to the power 1, or you say 5. So when you multiply this together, it will give you 1080, okay. That is all about this method. So the second method we'll look at now is the long division method. So the next method we'll look at now is the long division method. Now the long division method, or you say the shortcut method, it's a very simple one, okay, and that's the method most people adopt while solving this because it's easier and faster. Now the first thing you need to do to solve problem under this method, we're still going to use the same value. Find the LCM of 12, 27, and 40. Okay, so all you need to do now is you list out those numbers 12, 27, and 40. Now you check the least number that can divide through at least through 1 or 2 of those numbers. So 2 can go through. 12 divided by 2 is 6. 12 divided by 2 is 6. 27 cannot divide by 2 because there will be a remainder. So 40 divided by 2 is 20. Okay, now you move to the next one. What can divide again? 2 can go through. 6 divided by 2 is 3. 27 cannot be divided by 2. 20 divided by 2 is 10. Okay, so the next thing that can go through now is 3 can go through. 3 divided by 3 is 1. 27 divided by 3 is 9. Okay, 10 cannot be divided by 3. Now the next number that can go through there is 9. 9 divided by 1 is 1, cannot go through. So 9 divided by 9 is 1. And 10 cannot be divided by 9. So the next number there is 10. So 10 divided by 10 is 1. Okay, so to get the factors, now you multiply. To get the LCM, you multiply all these factors outside there. 2 times 2 is 4. 4 times 3 is 12. and 12. When you multiply all the numbers there, you get 1080. So that is all about LCM. So you can actually apply any of the two methods above, either the factorization method or the shortcuts or long division method, like we often call it. So the next thing we're going to look at now is how to find LCM of fractions. Okay, so we have a problem here to solve. Now find the LCM of 1 over 3, 5 over 6, 5 over 9, and 10 over 27. So the formula for finding the LCM of fractions is the LCM of the given fraction will be equal to, you find the LCM of the numerator and the HCF of the denominator. Now HCF stands for highest common factor. Okay, now we'll find the LCM of the numerator, that is the numbers at the top. Okay, now the LCM of the LCM of the numerator, that is the numerator from the problem here, is 1, 5, 5, 10. So the LCM of 1, 5, 5, 10 is simply 10. Okay, because all the numbers there, the numbers 1, 5, 5 are factors of 10. So the LCM of the numerator is 10. Okay, so we have 10. Then the HCF of the denominators are 3, 6, 9, 27. The HCF is 3. When you find the HCF, that is the highest common factor. The factor that is common among the listed number 3, 6, 9, and 27. The factor that is common there is 3. 3 can divide through 3, 6, 9, and 27. So the LCM of numerators is 10 and the HCF of denominators is 3. Okay, so the LCM of the fraction given is 10 over 3. So that is how to find or to solve LCM problems of fractions. Okay, so the last thing we'll look at under this topic is word problem in LCM. So we have a problem. Now word problem are simply problems in form of sentence where the reader needs to convert those things into mathematical term and simplify them. Okay, they are not straightforward questions. They are questions that requires you to think, look at the question, and deduce the mathematical content in it, bring them out and solve them. Okay, now 5 bells begins to toll together and toll respectively at intervals of 6, 7, 8, 9, and 12 seconds. How many times they will toll together in 1 hour, excluding the one at the start? So we have 5 intervals there: 6, 7, 8, 9, and 12. Okay, so what you simply do is to find the LCM of 6, 7, 8, 9, and 12. So if you find the LCM of 6, 7, 8, 9, and 12, it's going to give you 504. Okay, it's going to give you 504. So the next thing you need to check now is how many times will this bell toll together after each 504 seconds. Okay, so an hour is made up of 60 minutes. Okay, and 1 minute is made up of 60 seconds. So to convert 1 hour to seconds, you simply say 60 multiplied by 60, which will give you 3,600. So you simply divide 3,600 by 504. Okay, 504. Okay, to know the number of time that this bell will toll together. So when you divide 3,600 by 504, you simply arrive at 7. So it will toll 7 times. Okay,